Hello guys, I am Jonalyn Chua from BS Chem 1 Block 1. So for today's video, I want to tell you something about the example of packing numbers. Hello guys, good day. In this video, we have packing problems. This will be the first part of our packing problems. So suppose we have circles radius 1 centimeter, each of which will then have an area of pi centimeters squared. We are then going to fill a plane with these circles using square packing and hexagonal packing. So we will take up first the percentage of the square's area covered by circles. Then we will use area of the circles all over area of the square times 100%. To continue, so we have here an illustration. So assuming that this is the scenario here, we have to describe the circle inside the square. Then before that, let me introduce to you first the measurement of the sizes of our radius. So we have here first the center point of our circle and to the end point. We have 1 centimeter as our radius, and the second circle from the center point to the end point, we have 1 centimeter as our radius. So logically, to connect these two, we can have one side of an square. Then from this point to this point and this point to this point, we have every 1 centimeter as our radius, so that the size of our square is 2 centimeter. So okay, I think that is clear. To continue, so we have here the third and the fourth circle, the same way to construct the other sides of the square. So this is now the whole illustration. Let us proceed to our solution. Then we have to follow the formula here. The area of the circles all over area of the square. So start, we have area of the circle is equal to pi r squared, wherein our radius here is equal to 1 centimeter. So area of the circle is pi r squared. R is for radius and pi has its own approximate value, which is the 3.1416. To continue the simply, we have to substitute the approximate value of the pi here, which is the 3.1416, and the value of the radius is 1 centimeter with the power of 2. So that means to say 3.1416 times this 1 centimeter with the power of 2 is 1 centimeter times 1 centimeter. So I think this is our numerical coefficient. So 1 times 1 is 1. Then centimeter times centimeter, this is the cm with the power of 2. So this will be the 1 centimeter with the power of 2. So the area of the circle is 1 times 3.1416 is 3.1416 itself centimeter with the power of 2. So that is the area of our circle. So next to do is simply find the area of our square, since the formula of our area of the square. And to get the area of our square is we have the S with the power of 2, where is S is the size of the sides of our square, which is from here. We can see here from the center to the end point and the center to the end point. That is the one side of our square. So also they have 1 centimeter and 1 centimeter. So 1 plus 1 is 2 centimeter. From here to here, that is one side of our square, which is the 2 centimeter. So the size of our square is 2 centimeter. Then substitute the value of S, which is the 2 centimeter, or the side in our formula, the 2 centimeter with the power of 2. So we need to multiply these two. So 2 cm times 2 cm is equal to 4 cm to the power of 2. So this is now the area of our square. So we go back to this formula, that area of the circle all over area of the square times 100%. This formula is being used to get the percentage of the square's area covered by circles. Let's begin with the area of the circle. So we go back to this illustration to count how many circles we can inscribe and we can fit in this square. So let's count first how many 1/4 size of our square of our circle here inside the squares. We have 1, 2, 3, and 4. So 1/4 sizes of our circles will be added, and the result is 1 circle. We can fit in one circle inside the circles. We will only have to use the one area of the circle. We have 3.1416 centimeters squared, and the area of the square is 4 centimeters squared times 100%. To calculate, we need to use calculator here. The cancellation is centimeter and the centimeter. So let's start to calculate. 3.1416 divided by 4 is equal to 7854. The next is 100% multiplied by 100, and that is equal to 78.54 here. 78.54. So the percentage of the square's area covered by circles is 78.54. So we're done to our video. Thank you for listening.